Hello students. So now let's discuss about the 8051 interrupts, and let's find that how we can make use of interrupts in our 8051. Basically, 80 interrupts are the um, unwanted signals which a microcontroller gets from its hardware or internal software. So an interrupt is an external or internal event that interrupts the microcontroller to inform it that the device needs its services. So a single microcontroller can serve several devices by two ways. One is by interrupt and another is by polling. So there is a difference between interrupt and polling, and this is an important question as regard to with your examination. So interrupt is whenever any device needs its a service, the devices notifies the microcontroller sending an interrupt signal. Upon receiving the interrupt signal, microcontroller interrupts whenever it is doing the and serves the devices, and for that purpose it uses the ISR, interrupt service routine. So in polling method, continuously monitor a status of a device. When the condition met, it performs the service, and after that it moves to the another monitor the next device until everyone is serviced. So interrupt versus service means the polling method is not efficient since it wastes much of the microcontroller's time by polling devices that do not need the services. Advantage of the services interrupts is that the microcontroller can serve many devices, so each devices can get any attention of the microcontroller based on assigned priority. For the polling method, it is not possible to assign priority since it checks all the devices in a round robin fashion, and in the microcontroller can also mask the device and request for the service and interrupts. So here is the steps when we need to execute our interrupt. So it finishes the instruction it is executing and saves the address in the PC on the stack. Also saves the current status of the interrupts internally, that is not on the stack. It jumps to a fixed location of the memory and which is called interrupt vector table. The microcontroller get the address of the ISR and start to execute the interrupt service routine until it reaches the last instruction, and which is a RETI. So when we return from a call instruction, then it is RET, and when we return from interrupt, then it is a return RETI. Upon executing the RETI instruction, the microcontroller returns to the place where it was interrupted. So that's how it is working actually. So there is a main program. So when interrupt comes, then it jumps to the ISR, then main program, then it comes back to the main program. So it works like that actually. So 6 interrupts are over there. So there are one power up reset. 2 interrupts are set for the timers, timer 0 and timer 1. 2 interrupts are set aside for the hardware external interrupts, external 0, external 1 and external 2. It is connected at P3.3 and P3.3. Serial communication has a single interrupt that belongs to both the receive and transfer bits. So what events can trigger the interrupts in 8051? So timer 0, timer 1, reception and transmission of serial, external 0 and external 1, and one is the reset bit also can generate an interrupt. So it is an interrupt vector table. So it is the interrupt vector table start from 003, 0BH. 003H is for the external 0, 00BH is for timer counter, 0013H is for external 1, 001BH is for timer counter 1, 0023H is for serial port. So these are some important registers for the timer counter, for the interrupt. So TCON register is there, edge and type bits for the external interrupts 0 or 1. SCON register is for use the RI and TI interrupts. Interrupt enable register is there, enable interrupt sources and IP and specify priority of the interrupts, enabling and disabling an interrupt. And upon reset all timers, all interrupts are disabled, masked, meaning that none will be responded to the to buy the microcontroller. If they are activated, the interrupts must be enabled by the software in order for the microcontroller to respond to them. There is a register called IE interrupt enable register that is responsible for the enabling, unmasking and disabling masking the interrupts. So this is interrupt enable register. First is EA, which need to be 1 when all the interrupts need to be when all the interrupts are needed. Then ES is for the enable serial port interrupt, ET1 for timer 1 for timer 1, EX1 is for enable external 1 time interrupt, ET0 is for enable timer 0 control bit, EX0 is for enable timer external interrupt 0. So we can use them as like that also, and we can move the whole data as like that this also. So that is a bit addressable, so we can use a single bit for the active or deactive. So the priority of the register interrupts are like that: external interrupt first, then timer interrupt 0, then external interrupt 1, then timer interrupt 1, and then serial communication. So interrupt priority register, so we can change the priority of the interrupt register. So first 3 bits are reserved. Next is PS, and then serial port register, then timer 0 register, then timer 1, timer int 0 and int 1. So likewise this, if we want to assign a priority, then we can make it 1, and then the other priority will become lesser. So that's all about the interrupt register, and by this your 8051 microcontroller has finished. In the next lecture I will tell you about PIC microcontroller. Thank you.